Okay, we're going to, now that we've discussed oxidation numbers and hopefully we have a good handle on them. If not, the slide previous to this one has a quizzes review. I think it's 19 questions, so you can kind of go through and just make sure you are good with oxidation or determining oxidation numbers. So what is a redox reaction? A redox reaction is where electrons are donated or lost to another reactant. So here we say that if you look at reactant A here is losing this electron. It's giving it to B. And so we say that A is being oxidized. Why? Because it's losing an electron. B is being reduced. Why? Because reactant B is gaining an electron. So there's two parts. One is the oxidation and reduction, but they have to go together. So if something's going to be oxidized or lose an electron, something needs to gain those electrons, right? Like conservation of mass in a chemical reaction, matter can neither be created or destroyed, right? Okay, so here we have an electron being gained. Here's an easy way to remember. So oil rig. So oil is oxidation is loss. And then rig, reduction is gain. Another one, so there's like these little mnemonics that you have. I think there's one like Leo the lion, Leo. So loss of electron is oxidation. So Leo the lion goes gur. Gain of electron is reduction. So there's different ways, but just remember that's a redox reaction is an oxidation and reduction occurring at the same time in the same reaction, where one loses an electron, the other one will gain that electron. Losing the electron is oxidation, gaining is reduction. So here we have lithium losing its electron. So lithium is the one being oxidized, and then fluorine is being reduced because it's the one gaining the electron. So there's something called an oxidizing agent. That's the one that does the oxidizing. So fluorine oxidizes lithium, if that makes sense. Like fluorine is the one that gains that electron, so we call it the oxidizing agent. So by taking the electron from lithium, it itself is being reduced, but it's causing lithium to be oxidized. So we call it the oxidizing agent. Because lithium is being oxidized, it is donating its electron or losing its electron to fluorine, causing fluorine to be reduced. So lithium is the reason why fluorine is being reduced, so we call it the reducing agent. Something that might help is I always kind of just remember the one that's being oxidized is the reducing agent. And then the opposite is true. So the one that's being reduced is the oxidizing agent. Okay? So those are the things we have to remember. So let's do some practice problems. So let's look at magnesium going to 2HCl. So this reaction occurs, magnesium is higher than hydrogen. This is a single replacement, right? So you get aqueous MgCl2, magnesium and chlorine, plus hydrogen gas. Okay, so what's the first step to kind of like determine what's happening in this oxidation reduction? So the first thing we have to do is we have to label each element in this reaction by its oxidation number. So let's go ahead and do that. So I'll do that in orange. So let's look at what is the oxidation number here? Well, it's 0. What's the oxidation here? So hydrogen is a +1, chlorines a -1. So basically the skill that we learned of assigning oxidation numbers, we're now using that. This magnesium is a +2, all group 2 metals are +2, so it makes these chlorine -1. This hydrogen is 0 because it's neutral. All right, then we kind of look and we see, is there one being oxidized? So oxidation means that you're losing electrons, which means you're going to become more positive. Is there something that becomes more positive here? Well, check it out. Let me do this in green. So magnesium started at a 0 oxidation number. And now it's at a +2. In order to go from 0 to +2, that is a loss of a loss of 2 electrons, right? If you lose 2 electrons, you could become more positive by 2. So magnesium is being oxidized. Well, is there one being reduced? Something that's becoming more negative, or something that is losing electrons. Well, check out hydrogen. Hydrogen is a +1, but then now it's a 0, which means that it gained an electron. To go from a +1 to 0, you have to gain an electron. You're becoming more negative, if that makes sense. So hydrogen is being reduced here. And in this case, I'm going to put the ion. So magnesium, but here, remember, this is aqueous. So the thing that's being reduced is the hydrogen ion. Remember, the hydrogen and the chlorine separate or are dissociated. Okay. The oxidizing agent is the one being reduced. So my oxidizing agent is H+1, and then the reducing agent is magnesium. It's the one being oxidized. Now, the number of electrons that are transferred, we're going to write something called a half reaction. So the oxidized half reaction, so let's remind ourselves that is magnesium going from a 0 oxidation number to magnesium, which is going to a +2. Notice this is aqueous, so we're going to go ahead and, so this is what we call the this is the half reaction. This is what we call the half reaction for the oxidation part. So this is the oxidation half reaction. So there's a couple things we have to do here. First we balance the actual atoms. So I have one magnesium on each side, so that's cool. But then the second thing is we have to balance the charges. You'll notice that this side has 0 and this side's a +2, right? So we use electrons to balance this. How many electrons would we require to balance? Well, 2 electrons. And if you think about it, magnesium lost these 2 electrons to become a +2. What about the reduction half? So here we have the reduction half is hydrogen +1 going to hydrogen. So what do? How do we first balance this? We balance the atoms themselves. So I need 2 hydrogens on my reactant side. And then I'm going to actually kind of run out of space. I'm going to erase this. But how would I balance this? I have a positive, basically 2 on this side, right? Excuse me. So I have a positive 2 on this side. So I need 2 electrons on this side. And then what you'll notice is that I have 2 electrons and 2 electrons. So actually the electrons have to match. And I'll show you what happens if they don't match. But these electrons have to match for this to work. So how many electrons were transferred? Well, 2 were lost, and then 2 were gained in the reduction, if that makes sense. So 2 electrons. So that's how I figure out how many electrons are transferred. Okay, let's do another example. Okay, let's do this one. So we go MgO2, MgO. Okay, so let's first thing, you always identify the the oxidation numbers. So this is 0. These are 0, right? Because they are they're just neutral atoms. Magnesium here is a +2 because oxygen's a -2. So what's being oxidized? Well, let's check it out. Magnesium is going to a +2, so that's being oxidized because it's losing electrons, right? So magnesium, what's being reduced? Oxygen, it's going to a negative, it's gaining electrons. And so as soon as I have this done, I like to just, so my oxidizing agent is the one being reduced, so the answer is O2 here, and then my reducing agent is the one being oxidized, that's magnesium. Then to figure out the number of electrons exchanged, we just go into and figure out our half reactions. So my half oxidation is going from magnesium to Mg+2. Everything is balanced. I need to balance my electrons. And then O2 to O -2. So I need 2 oxygens, right? So the first thing, whenever I'm doing my half reactions, I balance my atoms first. So I have 2 atoms of oxygen on this side, so I need a coefficient of 2. But what that will do is, in total, there's actually 4 electrons that are exchanged. How did I get 4 electrons? Well, I started with 0, but now I have 2 oxygens that are at -2 charge, so I went to -4, if that makes sense. So I need 4 electrons on this side. Okay, so at this point, let's just stop and think about this for a second. So there's 2 reactions happening at once, right? The first is this oxidation, where magnesium is losing 2 electrons. And then there's a reduction where 4 electrons are being gained. But here's the thing. This, even though I broke it up, it's happening in the same reaction. So what I want you to see is in the same reaction, 2 electrons are being lost, but 4 electrons are being gained. Now, this does not follow the law of conservation of mass, right? And so what happens is we need to kind of almost double this, if that makes sense, so that we can get 4 electrons, but then in order to do that, that'll create 2 magnesiums here, right? And so the half reaction is actually 2Mg, 2Mg plus 2, and then 4 electrons, and then on the other side 4 electrons, O2, and then 2O2. And so the number of electrons that is exchanged is 4 electrons. So we want the number of electrons to equal each other, because you can't lose more than you gain, or you can't lose less than you gain, right? They have to be equal to each other. So sometimes we'll have to multiply everything, the whole half reaction, by 2 or 3 or whatever that number is. Let's do one more. So this one is this is a synthesis reaction where Fe plus O2 is going to go to, we're saying this is iron 3, right? So Fe2O3. All right. We can balance it if you want. So this is a 2. This is, nope, it's not going to be a 2, is it? It's going to be a 4. 2, and then 3. And then let's go ahead and figure out which one is oxidized and reduced. So let's count our oxidation, or assign our oxidation. So this is 0, 0. This is going to be a -2. All oxygen's -2. So this has to be a +3. What's being oxidized? Well, you got iron going to +3. So iron is being oxidized. It's losing electrons. Oxygen is going to a -2. It's gaining electrons. Right? So iron is being oxidized. It's also the reducing agent. And then O2 is being reduced, so it is the oxidizing agent. Let's do our half reaction. So we got iron going to Fe plus 3. And then we have oxygen going to O -2. So even though they have 2 and 3 here, I don't I'm not including them. I'm just focusing on the actual ion that it's going to. All right, so we got to balance, let's balance the oxidation half reaction. So Fe is good, so the atoms are balanced, but I need 3 electrons on this side. O2 is going to be, this will be 2, right? So my number of oxygen atoms are the same. However, I need 4 electrons on this side. So this is going to be interesting because 4 and 3 don't go into each other evenly. They got to get to 12. So I'm going to have to multiply this side. I'm going to multiply everything by 4 here. And then so that'll give me 12 electrons. And then on this side, it's going to be 12. But I'm going to multiply everything by 3. So this will be a 3. And then this will be a 6 here. So this will be 12 electrons. So the number of electrons that are being exchanged here is 12 electrons. And actually, if you go back, you'll see like, hey, here's 4 Fe, 3 O2 is there. And then in total, there are 4 irons. So here they are. And then in total, there's 6 irons, 6 oxygens, which are right there. So we're kind of just splitting apart this redox reaction. But it helps us determine how many electrons. This is the way to figure out how many electrons are exchanged. I have more problems in practice as well as you continue on in the end here. So feel free, there's a key as well posted.